All right. So you're having the one for chemistry, not for those things. Hey, you did not pick up a review. This is what we're going to do today. Anybody else need a copy of the review in Canvas? We're going to do all of that stuff on the back first. If we get through it fast enough and there's time to be able to do the review, I'm not sure vocab, could you nothing fancy? Managed to get it done in time for class. Didn't have to figure out what I did with my thing. For the opener, I do have some other stuff that needs to be passed back. A bunch of stuff. For this opener, when do you know when you are forced to use Avogadro's number to do a conversion? How do you know to use Avogadro's number? Oh, when you use the 6.02 times 10 to the 23rd, what unit's tied to it? A particle. So it could be, if it's an element, that's an atom. Okay, if it's an ionic compound, that's a formula unit, and if it's a covalent compound, it's a molecule, but they're representative particles. When do you know to pull the numbers off the periodic table? What unit is that always attached to? Grams. I did print these out, flow charts. I'm pretty sure I linked this in Canvas. Well, let me double check. Pretty sure I linked it in Canvas. Let's see. Yeah, mole conversion flow chart. It should be at the top of this week's module. Is where that is. So once again, Avogadro's number is tied to a particle. No, just this one. And Caitlin, did you say you needed to go? Oh. The periodic table is tied to the gram. Okay, I am going to go through the back of this review where it says problems. On the test, if you count like all the matching, there's like 4 parts that you have to match in a question. There's 13 questions on the test. A large portion of it is math. How am I going? And I give you the formulas for almost everything on the test too. The types that we're going to have to create a formula for on these problems is similar to the type that's on the test. This is just not the exact formulas and the questions on the test. It's the same processes. You have to be able to calculate molar masses of compounds. This is aluminum hydroxide. How do you calculate the mass for 1 mole of this compound? What do you do? Multiply it by the mass that's on the periodic table. So aluminum, there's 1 of them. And when you look it up on the periodic table, and we round to 2 numbers after the decimal, it's 26.98. And so no subscript means that there's 1. How many oxygens do you have?
3.
3 of them. You should know by now that oxygen is 16.00. We use it all the time. And then you've got 3 hydrogens, each one is 1.01. So how do you calculate then with these numbers? How do you calculate the mass of this compound? What do you do now? Just add them up. Yeah, 26.98 plus 48.00 plus 3.03, and it ends up being that 1 mole of aluminum hydroxide is 78.01 grams, or the way that they show it, it's the same thing, it's just said differently with the pre-AP classes, is it would be 78.01 grams per mole. It's the same thing. So if you were doing a conversion factor with this particular compound between moles and grams, if you're starting in grams, then grams would go down and moles would go up, and you would be dividing by the molar mass. If you were starting with a certain number of moles and you're changing into grams, and you would be multiplying by this molar mass. And that's not what this is just simply calculate molar mass. That's all this one is, and there is one like this on the test. And like I said, most of the formulas are provided for you. Do what? Yep, okay. Is there any question on how I did this? Or are some that are this simple? Maybe you're still writing down. Tell you what, let me take my attendance online. I'll be done. 10 minutes. It's over there. And if you do have questions, if you need me to go back over, point out where I found things, possibly calculator issues, today would be the day to try to figure that out. All right, so online I have Alexis, Declan, Jared, Lucas, and Reagan. I was a grading fool all day yesterday. Like I said, I do have a few things that I need to pass back. Right. Who's this? All right, then the next one, and I think I have them in the right order on here as it is with your paper. I don't think I jumped around at all. I want to know how many moles are present in a 450.0 gram of barium sulfide. All right. We're going to have to calculate its molar mass, yes. If you see grams, that's when you have to use periodic table. I gave you the formula that there's one barium, there's one sulfur, and there's 3 oxygens in barium sulfide. So I know that I'm starting with 450 grams, and that's going to go on this top left-hand block, but I have to use the periodic table with the fact that each barium is 137.33, sulfur is 32.07. Yeah, remembering right off the top of my head. There's 3 oxygens, each one is 16. So before I can actually work the problem, I have to calculate molar mass. Being able to calculate how many grams are in 1 mole of a substance is all over this test. And when I multiply them all out and I add them up, I find that 1 mole of barium sulfide is 217.40 grams. Now, if I was just asking for the molar mass, that would be your answer. But that's not what the question's actually asking you for. You just had to do that part first. What it's asking you to do is, starting with 450 grams of that compound, change it into moles. If you're starting in grams and you're changing to moles, you will be dividing by a molar mass. If you are starting in moles and you are changing it to grams, then you should be multiplying by the molar mass. But if you set these things up the right way, when you start with our 450 grams of barium sulfite, you should immediately drop down grams of barium sulfite. And once again, this flow chart is in Canvas. You need a digital version, or I have more paper ones if you need it. But going from grams to moles, then the mole should be on the top of the 1, and the molar mass, which you have to calculate, the 217, will go on the bottom. If you were going the other direction, if you follow the arrow, then the molar mass would have been on the top. And I do have some students that this finally helped. It tells you exactly how to convert, but this is the thing that helped them understand the baby steps of stoichiometry that we're doing. So I've got, with this conversion factor, the mole gets a 1, okay, and then I had to calculate that for the gram. And then grams cancels out. And we do not need to multiply or divide by 1, so I crossed all those out. And this is a division problem. There should be a simple calculator on the test. I don't know if I need to go back and change it to scientific. I might switch that and you can look at the details of the test. But you're probably going to be using your phone anyways, where if you The only problem is the regular one, at least that I have on my phone, I can't figure out how to make it go in and out of scientific unless I rotate the phone. I'm used to using a scientific calculator app, and when I got a new phone, I lost my app. But if you turn it sideways, when you do need the times 10 power thing, that's where you would get that double E. This case, when you do 450 divided by 217.40, and I'm going to round the answer to 4 significant digits. Let's see, it was 450, 17.40. I get a 2.0699172, and then so the second 9 made the previous 9, which then made the 6 round up. So this is the correct number of 6 bits. I am not going to try to trick you with like a bunch of answers that are almost all the same. It's going to be obvious which one should be the right answer. You still need to know how to use the calculator, and you know how to do the simple conversions. Most of your math on this are one-step conversion problems. And most of you are probably going to need scratch paper to be able to do this. Are there questions on how I did this one? How I calculated the mass or putting stuff in the calculator? We have 3.25 E21, or times 10 to the 21st, plutonium atoms. We want to know how many moles there are if I have that many plutonium atoms. Okay, this is an Avogadro's number conversion step. I know that because plutonium is an element, and I can go directly from atoms of plutonium, which is Pu, to moles of plutonium using Avogadro's number. The only thing that would make this an extra step is if this wasn't an element. Let's say this was like, I think the one that you guys have is nitrogen gas, or maybe it's one of the diatomics. The nitrogen gas isn't just N, it's N2. So if I was going from atoms to moles using nitrogen gas, then I'd have an extra step because one molecule of nitrogen gas has 2 atoms in it. Don't have to do that with this one. 1 mole of any element, I don't care what it is going to have Avogadro's number worth of particles. Whether it's gold, carbon, in this case, nuclear weapon material. You would cross out atoms. Ones don't affect anything. And it's just a matter of making sure you can put this in the calculator the right way. So I don't know how, with your Chromebook, I don't know what the calculator looks like. But if you turn it sideways and then clear it out, I would do 3.25. Do that E button, 21, divided by 6.02. Do that E function again, 23, hit enter. Now, if you don't have it in scientific notation, it's going to say 0.0053986 and a bunch of other numbers. I've been trained to write things in scientific notation, okay, but if your calculator is saying 0.005398, blah, 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 that's what this is. This is just in scientific notation. Let me show you how I did that. 0.00539886. Blah, 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 blah. You know the decimal is supposed to be after the first real number? And I want 3 numbers because of the 325, so that would be 5, 3, 9. This rounds that up, so 40. And then I had 1, 2, 3 jumps to the left, which is why it's negative. And now I'm in moles of plutonium. I'm also not going to try to trick you with scientific notation. They're the same thing. Are there questions on this one? If you do know how to do the math, you should be able to finish this test with no problem. If you're really struggling with math, you're probably not going to finish this test in time. All right. We have acetic acid. This is vinegar. Formula for acetic acid is CH3COOH. I'm starting with 1,200 grams of vinegar. I want to know how many molecules Oh, this should be a two-step. Did I not do this one right? I have to work this one on the board. Okay, I'm gonna change it to moles, and then I'm gonna add the other one on the side. Heck, I may as well just fix it now. Okay, so what I originally did was you're going to calculate. Let me move this over. All right, so I only changed it to moles. So you guys get to see how I build all these little puppies. It's amazing how much stuff I have to do just to do one problem. If I could just write on my board, I wouldn't have to do this, but I can't write on my board. Okay, so maybe me walking through this will help some of you if you're still a little confused. This is not going to be animated the right way. Okay, so get my line. It's not going to let me get my line. Oh, come now. I swear, sometimes I just want to punch this computer screen. All right, so I need another separation bar. Okay, so originally, you guys are just trying to write down all the answers. So we're going from grams to moles, but the question doesn't want me to go to moles. What does it want me to go to? Molecules. So I'm going to bring moles down, which of course now I don't really have. Let me make it smaller. So I'm going to go from moles to molecules. And I'm going to use Avogadro's number in order to do that. So I'm going to go MOLEC. Move this guy over here. So, and then the mole would get a 1. Get another one of these. So 1 mole has how many molecules in it? A lot. Avogadro's number's worth. This is just going to be a very messy slide. Okay, so that means Avogadro's number is going to end up going in this space as well. Let me move this over to the side. Well, if I can get it to behave, we need a 1. And then Avogadro's number is going to go up top. Okay. I'm going to have to make this go sort of diagonal, or it won't fit in that hole. Hopefully that doesn't bother you guys too much. All right, so then that means I need to add an animation, add an animation, add an animation, add an animation. All right. Okay, so I had to calculate the molar mass of the vinegar first. 2 carbons, each is 12.01. 4 hydrogens, each of which is 1.01. 2 oxygens, each of which is 16. And I add them all together. I get the fact that 1 mole of the vinegar is 60.06 grams. And then I realized this is how many molecules, and I've only calculated it to moles. Still doing the correct first step. I just didn't do the second step. So I'm starting, go forward. Okay, starting with 1,200 grams of the vinegar, and that should be over 1. I don't want to be in grams of vinegar, so I'm going to bring that down and over 1. And I have to first change it to moles. This flow chart, okay, this is what helps you. Starting in grams, you must first switch to moles, then going from moles to particles. That's when you use Avogadro's number. Like I said, this has helped a lot of my students in 8th grade that finally just snapped. And so 1 mole is 60.06 grams. And I know these are going to be like way animated out of turn. But then I need to bring down moles of acetic acid. And I'm going to bring it up to molecules of acetic acid, where the mole gets a 1 and the molecule gets Avogadro's number. So that means that this answer is not correct, because that is how many moles it is. So we're going to do 1,200 times 6.02 times 10 to the 23rd, all of that divided by 60.06. So what this is in molecules is 1.2 times 10 to the 25th. So I'm going to add that down here. 1.2, 1.2, E25. Now we're in molecules of acetic acid. And now that's right. Not that I was necessarily doing something wrong. I didn't read the question right when I was working it, and I stopped at moles. But literally, all you do is you take the two one-step conversions and you smush them together. Because if I do it this way on the board, 1,200 grams to moles. If you literally shove these together, where this would line up on top of here, that's how you do get, I mean, I could do two separate one-step problems, because this essentially calculated out to 20 moles. Then when I multiply that by the 6.02, I'm still going to get to the same answer. I just smushed them all together. All right. And you do have some two steps. If you have to be able to go from grams to molecules on this review, you're going to have to be able to do it on the test. All right, how many atoms of nitrogen gas are there in 3.1 moles of nitrogen gas? I can't go directly from moles to atoms because nitrogen gas is N2. I know that a mole of nitrogen gas has that many molecules, but how many atoms are in nitrogen gas? One molecule of nitrogen has how many, of nitrogen gas has how many nitrogens in it? No. One of these has two atoms in it. But you need to know that nitrogen is a diatomic element. Nitrogen is not the one that's on the test, but if I asked you of chlorine gas or oxygen gas or fluorine gas, then you have to know that there's two of them. And once again, for this flow chart, that's what's helping you. You're starting in moles of nitrogen gas, which is a molecule, and then we're going to go from molecules to atoms. Start with 3.1 moles of nitrogen gas. I have to go from moles to molecules first. And then I'm in molecules. I'm going to drop down and I can go to atoms. But I'm getting my numbers from the conversion factors that are above the stoichiometry cost. I'm going to let you guys. I am planning on letting you guys use the review to help you with the test. Like I said, it is not the same question. It's the same process. I ask you to like go reverse direction, but and so to go between moles and molecules. In this part, because they can't see me pointing at the board. So this part, you're going from 1 mole to Avogadro's number worth of molecules. And then you're going to use the conversion factor underneath that, where 1 molecule has 2 atoms in it. You're going to make sure everything crosses out. Ones don't affect anything. This is a straight multiplication number. (3.1) times 6.02 E23 times 2. And I'm going to round it to 2 numbers in the coefficient because 3.1 has 2 numbers in it. And it's 3.7 times 10 to the 24th nitrogen atoms. I don't care if you do times 10 in a superscript between E. I use an E because it's faster. Means the same thing. No matter me. In fact, on the test, because of the way that Canvas does certain things I type in. If it's in an instruction, I can do a superscript or a subscript. But if it's an answer choice, a lot of times I can't do a superscript or a subscript. So I just use an E. Are there any questions on this one? Okay. Head composition. Most of you seem to pick up on this pretty easily. I did notice if you got them wrong, it was the two that asked, what is the percent composition of like the sulfur dioxide in the sulfuric acid? Those were the ones I noticed that were not being done right. I won't pass those back in a bit. There are two aluminums in aluminum carbonate. H is 26.98. Still have to do the mole mass first. There are 3 carbons, each one's 12.01. Then there are 9 oxygens, each one is 16. Now I have to add them up first. Molar mass is 233.99 grams. Now, how do I get the individual percentages? What were we doing yesterday and the day before? How do you use this molar mass? The total amount for each individual element by the entire compound, then times 100. For aluminum, ends up being 23.06%. For carbon, it ends up being 15.40%. And for oxygen, it ends up being 61.54%. It should roughly add up to 100. If you round just a little bit off, it may not be, we picked 100.00, but it should be pretty close. I can't remember if I gave you another, because I added stuff to this video. No, okay. This is the type of math that you have to be able to do for the test. Not these exact compounds. It's this type of math. Now the rest of it is all vocabulary, which is matching it before. I can do the pass this stuff back. And within the top 3, you can get extra 10 points on the test.
Yeah. So, you
weren't doing the right thing on the one paper. You were, I think, just calculating the mass, and you were supposed to be. I can't remember. No. One I just passed back. Doing the wrong thing. If you get a check mark, it's a 100.
Yeah.
The only thing I've not put in the portal is the 2% composition ones. You have to. Sometimes you have to like hold that so that it doesn't have the right contact. All my sharpeners have been dropped multiple times, so they just go. All right, the other thing that I have done for you, was there any question math-wise with what we just went over? Okay, so I have to change the way I'm presenting here. You have to bring up, you guys are not doing the Paleozoic era. I have to mute my mic or it sounds horrible.